In our last set of videos, we discussed and reviewed firm valuation using the discounted dividend model. This is going to be our starting point, but we're quickly going to extend this into the discounted cash flows model. Before we do so, I want to present some of the issues with the discounted dividend model from our last set of videos. We know that we value bonds by taking the present value of their future cash flows. So why wouldn't we value stocks using the same method, the present value of the cash flows from stocks? And what are the cash flows that investors receive from stocks? Dividends. There are two major problems with valuing stocks using dividends. One, how do we value non-dividend paying stocks? Google, for example, does not pay dividends. Even though it has quite a lot of cash, what is it doing with its cash and its profits? It's investing in just about everything under the sun. So rather than giving cash back to investors, it just makes more investments, assuming that that's what the investors want them to do, to keep investing into productive purposes rather than just paying cash out to those shareholders. Second problem with using the discounted dividends model, we mentioned previously that financing activities, dividend payments are financing activities, are not value generating. Dividends are distributions of firm value. So financing activities, including dividends, it's a type of financing activity, are not value generating. Dividends are distributions of value. We can confirm the fact that dividends do not generate value by examining a dividend-paying firm's stock price before and after a dividend is issued. A firm's stock price will drop by the amount of the dividend at the time that the dividend is paid. Technically, it won't drop on the day the dividend is paid. It'll technically drop on the ex-dividend date, but that's outside of the scope of this class. So we know that dividends don't actually add value to a company's stock. So how else can we measure firm value? In this video, we are going to look at the discounted cash flow model. Remember we said financing activities, or cash flows from financing activities, are not value generating. On the other hand, operating cash flows and investing cash flows are value generating. So what are the value generating cash flows? Those from operating, and remember, operating cash flows are the day-to-day activities running the business. The cash received from sales to customers and the cash payments for running the business, salaries to employees, buying inventory from suppliers, interest, taxes, and so forth. And investing activities. What does the company purchase in order to earn a return? It purchases plant, property, and equipment in order to run its business, which to earn a return. And if it has excess cash, it's probably going to put that excess cash into some investment securities with the primary intention of earning a return. So the fact that operating and investing cash flows help generate value should be straightforward. Operating activities relate to the company's primary business purpose, and investing activities are made specifically with the intention of earning a return on invested capital. Therefore, we can value the firm by forecasting its operating and investing cash flows. This makes sense because in our last set of videos, in Chapter 3, we looked at how we can value a project by adding the present value of each one of the project's cash flows. A firm is equal to many projects combined. So what we can do is simply take the cash from operations. Of course, we're looking at projecting this, looking at forecasted future cash flows from operations, less cash paid out from or for investments. And this difference we are going to refer to as free cash flow. So this is the net of the cash flows that relate to value generating activities. Typically, a firm begins by making initial cash investments or cash outflows. It's going to be the things like buildings, land, equipment. And those are expected to result in future operating cash flows. The cash received from sales to customers, less the expenses of running the business, paying for those goods that made up the inventory, paying our employees their salaries, advertising, and so forth. We can consider the value of a firm to be equal to the difference between the cash inflows from operations and the cash outflows for investments. And again, we call this the free cash flows. So the discounted cash flow model this is an extension of the discounted dividend model. But instead of looking at dividends, which we said are not value generating, we can look at free cash flows. This says that the value of the firm is equal to the present value of its future free cash flows. So we can predict out free cash flows in year 1. We present value them by dividing by 1 plus the required return, R. Add our estimated free cash flows in period 2, the end of year 2, discount that 2 years, and so forth, all the way as far out as we are willing to go to end that certain number of periods into the future with which we expect the company to continue. And R is that required return or discount rate on the stock. And this makes sense for the non-constant growth firm. One thing I want to mention before I proceed is that what we're looking for is the value of the firm. The value of the firm is equal to the value of equity plus the value of debt. And the reason that we make this distinction is because at some point soon we are going to start examining the value of the equity. What are the shareholders looking for as their return? And when we do that, obviously what we're going to need to do to get the value of equity is rearrange this formula above to be the value of the firm, which is what we're finding when we're taking the series, the present value of all of the expected future cash flows, and then subtract out the value of the debt. And we can find this in the balance sheet, or we can find the fair value of the debt in the footnotes to the financial statements. At this point, we'll just be given what that the value of the debt is. Okay, so returning back to the discounted cash flow model, this is our focus for this set of videos, Chapter 4. Again, what I said earlier is that this model shows how to value a how to value a constant growth firm. I might have said a non-constant growth firm. This is how we value a constant growth firm. Remember that when we saw a similar model in the discounted dividend model, we took the present value of each cash flow. And when we extended the basic discounted dividends model to a non-constant growth stock, we had to edit our model. So we're going to edit our basic model here similarly. Remember, we said we found the present value of each cash flow during that initial non-constant or supernormal growth period. And then we said at some point in the future after that, the stock will become, or the firm will become a constant growth firm. And we could find the price of the stock at the end of the constant growth stock. The same procedures apply when we're using the discounted cash flow model. We estimate the future cash flows during the non-constant growth period, and then we value the firm at the end of the non-constant growth period using the present value formula for a constant growth stock. As an example of this, I'm going to turn to example that's shown in the textbook in Chapter 4. This is Exhibit 4-1. It's the discounted cash flow valuation for Coca-Cola, assuming that it's a non-constant growth stock. We have, we're looking at data from 1999 to 2004. We are trying to find the value of the stock in 1999 based on our expectations of the cash flows or free cash flows in 2000 through 2004. We are estimating that this is, the company is going to become a constant growth stock in 2004, and the cash flows in 2000, 2001, 2002, 2003 are all during a non-constant growth period. 2004 becomes a constant growth stock. The company has a required return or a discount rate of 9%. So we are going to discount each of these cash flows back at 1.09. And let's walk through how to value this non-constant growth stock. I took this data from the textbook and put it into this template worksheet here. And so here we have our cash flows from operations. We're given our cash inflows from operations and cash outflows for investments. The net of these two is our free cash flow. So here's the information that we need to solve for the discounted cash flow model. It's going to look exactly the same as the discounted dividend model, except instead of predicting the dividends, we're going to be using cash flows. So this should just be a review. Let's work this out on a timeline where here we're going to have, this is time 0. Here we have year 2000's cash flows, 2001. We know that we have non-constant growth through 2003, and then after 2003, the company, we expect the company to have constant growth in the cash flows at a rate of 5%. So to value this stock, we are looking at the price at time 0, which is right now, or 1999. We're going to look at the net free cash flow in each period, and what we need to do is discount it back to the value today. Discount rate is 1.09. 2001's cash flows, 2910. We're going to discount that back for 2 years. All right, in 2003, we have our cash flow of 4551. We want to discount back. I think I skipped a step. I think I missed discounting 2002's cash flow. And if you're thinking we could have done this, we could be finished by now by doing this in Excel, you are absolutely right. But it wouldn't be as much fun, nor would we see exactly how the steps are determined. All right, so this works out to be, hopefully you have a calculator that has the exponent function, so you can just simply get the present values. We will not be using Excel or our computers for quizzes or exams in class. So clearly you're not going to get any problems that go out more than 5 years. This is 3224, and we still need to present value this last cash flow because we are going to expect to receive that. 5311. Data was just given. Let's present value that back. Oh, sorry about that. But we're not finished. Once we put in this last cash flow once it becomes constant growth, all we have is the present value. When we're looking at the value of our stock at time 0 right now, we have the present value of the next 5 future cash flows. But after 2003, this company becomes a constant growth company. So we want to find the price at 2004. oh, sorry, I believe this should say after 2004, the cash flows grow at a constant growth rate of 5%. So what is that? Price at 2004. Well, remember what we do once the company becomes constant growth. We take the next cash flow, which will be, it will grow at a rate of 5%. So this is their next cash flow, just like we used D1, or the next expected dividend, in the discounted dividend model. Now we're using the next cash flow. The difference between the required return and the constant growth rates. So when we calculate this out, we will get 139,414. But we can't add 139,414 to our cash flows, because this is the value of the firm at 2004. Remember, we are looking for the value of the firm at time 0. So what we need to do is take the 139,414 and discount it. Divide by 1.09 to the 5th. Now, how come I use my denominator of 1.09 minus 1.05 up here? That's because we are trying to find the price at 2004. Remember, this is similar to taking our D1 when we use the discounted dividend model, divided by R minus G. Now, instead of the next dividend, we are simply taking our next free cash flow, dividing by R minus G. And what we get is the price at that point in time, at 2004. We need to discount this value of the firm at 2004 into today's dollars. So we discount by 1.09 going back 5 years. This will become 90,609. And now, to get the value of the firm, what I want to do is add up all of these cash flows. I will get 104,977. This is the, I don't know where, oh, there it is. Computer likes to play tricks on me. This is the value of the firm, times 0, 1999. And if what we're trying to get to is the value of the equity, well, what we do is subtract out this, the value of the debt is given in this problem, 4435. So we subtract out the value of the debt. Again, this is given. And we get the value of the equity is the difference, 100,542. If we divide this by the number of shares outstanding, which we are given, what are we going to get? Number of shares outstanding is 2472. We get this number, 4067, and what did we just solve for? We just solved for the equity value per share. And you can understand why the investor would be interested in this number. All right, the next thing I'm going to do is work this out in Excel. So this is the information. Let me go back to here is what the template looks like in the textbook. You see what we did in our last exercise is we manually took the present value of each one of these cash flows. We wrote 1.09 to the 1, to the squared, to the third, to the fourth, to the fifth. They're just giving you that discount rate. To get the present value of those free cash flows, these are the numbers that we solved for before. When we add up this number and this, and this, we get the 14. The continuing value, this is where we took the next cash flow, 3452 times 1.05, divided it by the difference between the required return and the growth rate to get the 139,414. But then we needed to present value that back to today's dollar terms by dividing this by 1.09 to the fifth. We're going back 5 years. This gives us the value of the firm, also known as the enterprise value. Subtract out that given book value of the debt, gives you our value of the equity, divide that by the number of shares outstanding to get the value of the stock, of 1 share of stock. In this last worksheet here, I've worked out the solution step by step, so you can see in each cell how I calculated the present value of each cash flow, which shouldn't be too difficult, how I calculated the continuing or horizon value. So if you'd like to work through it on your own, you can use this template here to try to think through how do we do this in Excel, and you can check your work to the solution. I hope you enjoyed this video. In our next video, we are going to extend this model.